Probably the most popular reason for setting up home automation using Home Assistant, for example, is to automate the lighting. Now, Home Assistant does support a lot of different motion sensors, different smart lights and switches, but it also supports ESPresence, for example, which allows you to detect where people are in the house. But what about the actual automation rules? How do you actually set up rules to turn the lights on when somebody enters a room, but then turn the lights off once the room is actually empty? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, because this video is specifically about the automation rules for lighting, then I'm going to assume that you've already got Home Assistant installed and configured, and that you've added in the motion sensors and smart light bulbs or switches for your rooms. I'm also going to assume that you've got Node-RED and ESPresence installed and configured. Otherwise, if I have to cover those as well, the video would just get too long. Now, if you don't know how to actually set those up, then I do have several videos that might help, and you'll find those in my Home Assistant playlist. Now, most of the time you only want to turn a light on if it's actually dark. And there are different ways that you can handle that, but what I've done is to set up a virtual switch, or in this case for Home Assistant, a Boolean helper that will tell me if it's nighttime or not. And what I've got is a rule that will actually turn that virtual switch on or off depending on whether it's sunrise or sunset. So what I'm using here is the big timer node. If I double click on that, I've got it set to on time as sunrise, off time as sunset. In other words, big time is just an on-off switch for sunrise and sunset. I could put in offsets if I particularly wanted, but the key thing here is that I've got to give it the correct coordinates. And what you can do to get those is go to Google Maps, for example. So let's say, for example, we decided to live in Caesar's Palace in Las Vegas. Find that in Google Maps, and if you right click on it, what you'll be able to get is the actual coordinates here. Then you can feed those into the actual node to get the correct sunrise and sunset for where you live. Now, once you've actually got that set up, the only catch is the output isn't on or off. You either get a one-off message, a message every minute, or this speech/log output. So we need to actually convert that into something we can use to turn our virtual switch on or off. And to do that, I'm using this switch node. So what it does is to basically take that one-off message, because that's all I'm interested in. I just want to know when it's sunrise, send me a message. When it's sunset, send me a message, and then I'll act on it. So what the switch node's doing is basically taking that message, which will either be on or off, and then it's creating outputs for those. So I've now got an on output and an off output. Now, if big timer here turns on, then it's sunrise, in which case it's daytime. So what I do is, when that happens, I turn my input Boolean or virtual switch off. On the other hand, when we get a sunset and then big timer turns off, we'll get a message out of the off output, and we want to turn our switch on, because that's essentially all I'm interested in, really, is just knowing if it's nighttime or not. Now, what I'm referring to here is virtual switches. Home Assistant calls Boolean helpers. To create those, what you can do is go to Settings, click on Devices and Services, select Helpers, and then what you can do is create a helper. Now, this particular one is just a toggle switch. So in other words, it's just something simple. It's just an on-off switch. That's why I refer to it as a virtual switch. So there's mine down there called nighttime. But by setting that up, it allows me to have a means to actually track whether it's nighttime or not. And then when I actually run my rules, I can actually check if it's nighttime, then yes, I would want to actually turn the light on. If it's not, well, no, I don't. Now, some rooms in the house are what I'd call transit areas. In other words, someone will walk into the room, but more or less straight away, they'll then walk into another room. In other words, they don't stay long enough for a Bluetooth tracker to be of much use. So I just rely on the motion sensor and a timer. So in this example, we've got a motion sensor for the hallway. When motion is detected, we'll run a check to see if it's nighttime, because we only want the light turning on if it's dark. So what I'm doing here is to check if our input Boolean, our virtual switch, is set to true. If it is, then we send an instruction out to turn the light on. Now, I would actually like to run an additional check just to try to keep the load on the actual network as low as possible. And that is to actually check if the light is already turned on, because if it is, there's no point turning it on. But that does delay turning the light on, and I want that light to come on as quickly as possible, so I'm not doing that. We'll just check, is it nighttime? If it is, then turn the light on. Now, once motion is cleared, the motion sensor that we've got here will send a message out that Home Assistant and Node-RED will pick up. And then what we'll do in this case is start a timer. Now, rather than using the timer on the motion sensor, I've got a separate timer because I can control that. It's much easier for me to control this one than it is messing around with the actual settings within the motion sensor itself. So basically what's going to happen is someone will walk into a room, trigger the motion sensor. Assuming it's nighttime, the light will come on. Then once the motion is cleared, in other words, they've left the room and motion is no longer being detected, we'll get a message, we'll start our timer. Once that's expired, then I'll make a check to see if the light's on, because there are other circumstances, other rules that I've got that could possibly turn this light off. In which case, if that light is on, I'll turn it off. Otherwise, there's no point because it's already off. I don't mind having that extra check because it's just delaying turning the light off. I'm more concerned about getting that light turned on as quickly as possible than I am turning the light off. Now, one thing to point out though is that this is a stop time node. The reason being is that I actually want to be able to stop that timer. I find it to be extremely useful to be able to do that, especially in rooms like this. The only trouble is it's no longer included as part of the default nodes. You have to actually install it. To do that, you go to the menu. You then go to Manage Palette. Click on Install. If you just type in Stop, right at the top, it's the first one you see, this stop timer that we've got. So you can see I've already got it installed, but it hasn't been maintained for a long time. But all the same, I find it to be extremely useful. Because let's say, for example, somebody walks into the room, it's nighttime, we turn a light on, then they leave, a timer then starts. Now that timer is going to run down, and if this had been a normal timer, there's a possibility that somebody else could then walk into the room just as that timer expires, and then the lights would turn off. By having this, what will happen is motion will then get detected again. We'll then come to make our check, is it nighttime? Well, in this case it is, but what I've done is I've altered the payload that's being sent out, which is a stop message. That does get sent to this node that we've got to turn the light on, but it doesn't matter. All this does is it's just going to turn the light on regardless, so it makes no difference what payload you send that. But I am sending this payload out to the actual stop timer node that I've got, and what that'll do is actually stop the actual timer, in which case we're delaying turning off the lights, which is extremely useful, I find. Now, one other thing that I'm doing is to actually check during the daytime if the actual area, the room itself, is actually dark, because you can have dull and overcast days. So what this node here is doing is to check if it's nighttime. If it's not, then obviously it's daytime, in which case I'll run a check here to actually see what the lux level is. In this case, it's a setting of anything less than 3. It's going to vary depending on your sensor. It's going to vary depending on how you place that sensor and so on. But I've got a lux sensor that's built into this motion sensor, so I can find out what the light level is in a room. So during the daytime, what will then happen is if the actual lux level is too low, I'll be able to get it to turn the lights on. On the other hand, if it's a case of motion's no longer being detected, we'll get the same timer, it'll kick in and start, it'll do its countdown. If motion does get detected again, then this is going to do the same thing as that node over there. In other words, I'm altering the payload to say stop. So it's doing the same thing as this one, except essentially it's for during the day. Now, originally, I did just use the actual lux level sensor. I didn't bother with this nighttime check. The reason being was, well, I've got a lux level sensor. Well, why not just use that? The only problem I've found is that the actual sensor, it doesn't update quickly enough. It's actually configured to send reports out pretty quickly, but it doesn't actually detect the light level actually changing quickly enough. So I've had situations where Murphy's Law, I've literally walked into the room just as the lights are turning off. The problem is the lux sensor doesn't detect that quickly enough to update Home Assistant. Motion is then detected and triggered, but the trouble is, as far as Home Assistant and this lux level sensor are concerned, it's still light, and so the light doesn't turn on, so the lights have been turned off and it's still dark, and I've got to wait for this sensor to update, and I've got to wait for the motion sensor to clear. So for that reason I swapped over to just using the nighttime check instead, and then on the off chance this will kick in during the day on those occasions where it's dull or overcast. But it's usually light enough that it's not that much of a problem, but it's still useful to have all of the same. Now, although ESPresence can tell us which rooms people are in, what we're really interested in for our automation rules is knowing if a room is empty or not. So for that reason, I've been setting up some additional virtual switches. So we've got this one here, David_bedroom, this one here, David_kitchen, and this one here, David_study. So the idea is, if I'm in the actual bedroom, then this one will be turned on, and these two here will be turned off. So that way I know, based on these virtual switches, which room I'm actually in. So you'd have one for every room and one for every person for every room. So it does build up, but it's a logical way of finding out which rooms people are in. I've then got a sequence, and you'd have one for each individual person and the actual wearable that you're tracking, which tracks the actual device, and then when it moves to a different room, we then react on that to turn a specific virtual switch on and all the rest of them off. So in this case, this is tracking my watch. So if we look at the actual node, there's not really anything I can do within the actual node itself. What we're really interested in is just knowing, has this watch moved to a different room? But what I have done is to basically get it to ignore a state of not_home. So that can happen if you're moving around quite a lot and the base stations aren't picking you up, or if you actually just leave the house entirely. I'm not actually going to do anything within the context of our lighting based on that. So that's the reason I'm just setting up to say, if the state is not home, then it must be something else. It must be the study, it must be the kitchen maybe, or it must be the bedroom. It's got to be something other than not home. And then I'll actually do something. And what I do is to output that result to the switch. And then with a switch, I can then split this up and do something depending on which room that device was detected in. So if you have a look at the switch, we've got different outputs, one for the study, one for the kitchen, one for the bedroom. So these are just based on the actual payload, and the payload that we're getting is the actual room that that device was detected in. So if the device moves and it says it's in the study, it goes out that output there. If on the other hand it says kitchen, it'll go out that one. If it says bedroom, it'll go out to that one. Now, I don't use it for the bedroom anymore because I've got other rules handling that. But let's say, for example, it says we're in the actual study. Then it'll go out this output here, and it comes to this check here. Now, the reason I've got this is a check just to go back and double check, is the watch actually saying I'm in the study? The reason for that is I used to have stability problems with Room Assistant, for example. What I'm finding is ESPresence is a lot more stable, so technically I don't need that check anymore, but I'm leaving it there just in case. I've got other rules dealing with stability, which we'll cover later. But essentially all it's doing is it's just doing one final check just to make sure nothing has changed. I mean, it's so quick, it probably wouldn't happen anyway. Whereas with Room Assistant, I would have set some sort of delay here in the timer. But in any case, assuming we've actually been moved over to the study, then what we'll do is we'll turn on the actual virtual switch called David_study. And at the same time, we'll then turn off the others. So David_bedroom and David_kitchen. Same will happen if the actual device gets picked up as being in the kitchen. It goes out this output, goes over to here. We do one quick check to see, well, is the actual watch still saying we're in the kitchen? If it is, then we turn on David_kitchen, and then we turn off David_bedroom and David_study. So that means I've now got virtual switches which will tell me which room I'm actually in. And you do that for every person that you've got. Now, although these virtual switches aren't telling us anything different to what the device trackers are, the key point is that I can actually take advantage of these virtual switches to create room occupancy sensors. So in this example, what I've done is to create a file called occupancy.yaml. You can call it whatever you like. You can even include the contents that I've got here in the actual main configuration.yaml file. But if you are going to create a separate file, then you do have to tell the configuration file about it. It's a template that we've got, so I've had to reference that there, and then I've told it what actual template file to include here. The key point is that I'm setting up sensors, one for each room. So these are going to be my occupancy sensors for the different rooms that I've got. So I've got one called kitchen_occupied and one called study_occupied. Now the state of these actual sensors is dependent on virtual switches that I've got. And you can have several of them. You can have one for each individual person that you're tracking. That would be the idea. So that if any one individual is in a room, then the actual room sensor will be on. On your hand, if nobody's in that actual room, the room sensor will be in a state of off. So what it's doing is it's just checking the state. In this case, I've got a David_kitchen virtual switch, and it's checking to see if it's on. So if that's on, then that warrants turning this kitchen_occupied sensor on. Or on the other hand, if the one for Frank's turned on, then yeah, that sensor will be in a state of on. The key point is because we're using the OR operator, what it means is that if none of these virtual switches are turned on, in other words, they're all turned off, then this sensor will be turned off. And that's really more what we're interested in for the actual lighting rule is when the actual room is empty. But it's pretty straightforward to actually set this up, and you can set it up for, as many people as you like, really. I mean, I've just got 2 people here just to demonstrate that I'll be able to track multiple people across multiple rooms. As long as one person's in a room, then the occupancy of that room is on. If no one's in, it's off. Well, now that we've got room occupancy sensors, we can take advantage of those to actually keep lights turned on in a room if the room is occupied. So in this example here, we've got a sequence for the kitchen which looks pretty much just the same as it does for the hallway, except that I've got to check here to actually find out if the kitchen is empty before we decide to turn the lights off. So usually what would happen is someone will walk into the kitchen. If it's nighttime or it's daytime and cloudy and overcast, the lights would get turned on. Because people are spending quite a bit of time here, at some point the motion sensor will stop detecting motion, the timer will kick in which case what we'll then do is actually check, is the actual kitchen occupied or not. So specifically, I'm actually checking to see, is this set to false? In other words, is it set to off? Is the kitchen actually empty? If it is, I'll do one final check to see if the lights are on. If they are, we'll turn them off. On the other hand, if somebody or several people are actually in the kitchen, then nothing happens. The room is occupied, so we don't need to do anything. We want to keep the lights on. Eventually what's going to happen is either someone else will walk into the room or people will get up and leave. And what will happen then is this whole process will start again where motion gets detected. It'll go through that process of turning lights on. And eventually, when everybody has left, this time what will happen is the motion sensor will stop detecting motion. The timer will kick in. And then when that expires, we'll get to this point. It'll check, is the actual kitchen empty? This time it'll say, yes, it is. So we do our check, the lights on. If they are, we'll turn them off. Now, when I originally set up some rules to take advantage of presence detection, they actually look like this. In other words, I've got one rule to turn lights on, and then I've got another rule to turn lights off. The reason I've done that is that a motion sensor is quick to react, whereas an actual presence detection system isn't. My watch, for example, sometimes might take 30 seconds, sometimes even a minute or more before the actual presence detection system realizes that I'm in another room. So that's no good for actually turning lights on, whereas the motion sensor is. It's much, much quicker to react. On the other hand, the motion sensor isn't good at detecting actually any presence in a room, whereas the actual presence detection system is. So that is why I've got a motion sensor rule to turn the lights on, and then a presence detection rule to turn the lights off. Now the rule that I've got here to turn the lights on is really just the same as the one that I was showing before. If I bring that rule back in to view, you'll see the only difference between this rule and this rule is that this one's got this extra timer that's being run. In other words, when this motion sensor stops detecting motion, it then results in a timer starting, which will eventually turn the lights off. For this one, on the other hand, that isn't actually being done. The reason being is that we've now actually got a completely separate rule to turn the lights off. So for this rule to actually turn the lights off, what we're doing is to monitor the occupancy switch for the room. So in this example, it's the kitchen. And if I look at this node, what it's doing is it's just looking to see when this actual virtual switch I've got called kitchen_occupied turns off. In this case, it's just using the logical state of false, but it's the same thing. So when this switch turns off, in other words, everybody has left the room and it's now empty. In other words, there are no device trackers reported in that room. We then start a timer. The goal then is, once the timer expires, we'll do a check to see if the lights are on. And the reason being is that I don't want to waste network bandwidth turning lights off if they're already off. But what I do want to do is to actually check to make sure that the actual room is still empty after that timer has expired. If it is actually empty, then we'll turn the lights off. Now, the only thing is, once that timer starts, it is possible for somebody to just walk back into the room, in which case I've got this extra check over here where we're actually checking for motion. So if motion then gets detected in the room again, I'm going to get this actual node here to send out a stop message in the payload. The reason being is I'm using this stop timer. And when you send a stop message to the stop timer node, the timer then stops. So if, for example, everyone has left the kitchen and then somebody then comes back, that'll result in the timer being stopped, because then the motion will have been detected and then that will turn the timer off. Now, it is also possible to get a situation where they did come back too quickly, in which case the motion sensor itself didn't clear, for example. You can also have a situation where you get what I would refer to as device drift. This can happen, I find, with these Bluetooth systems. I've had the same issue with Room Assistant as well as with ESPresence, where a device is in a specific room, but the signal is getting weaker and weaker. You're very much reliant on how often that device is broadcasting out by the looks of it. But you can get to a situation where you're not getting an update quickly enough and the device is getting further and further away from the base station as far as it's concerned. And you get to a situation where the device might either jump to another room or it might jump to being not home. It seems to vary. You can alter the distance filtering on those base stations to try to deal with it, but the only trouble is I find that different devices can have different signal strengths, they can have different frequencies and so on. So for that reason, I put in an extra means to stop the actual timer. So let's say, for example, I'm in the kitchen and I'm the only person actually in that kitchen. As far as Home Assistant's concerned, the device tracker is saying I'm in the kitchen. So that room is now flagged as being occupied. Then for whatever reason, the device moves and it's now saying I'm in the lounge, for example. Well, what that will result in is, because I'm the only person in the actual kitchen, my room occupancy sensor is then going to turn off. It's going to result in triggering this node. Once that node then triggers, it's going to result in a timer starting. Now, if I don't move around, this is not going to trigger it and then stop the timer. So I've got this extra check in here, because what should likely happen then is, at least within that 5-minute time period, is that the device will then resync and it'll come back to being in the kitchen again. Sometimes I find I might have to wake the actual watch that I've got up again. I might have to press the button to get it to resync again. That seems to be more of a problem with the device than the actual system, I suspect. But either way, what will then happen is this node will trigger again, but this time the result will be, well, actually the virtual switch is on, the room is occupied. So now what we'll get is the output coming out here. The reason I'm doing that is because I can't send a stop message from this node itself. This is the one that's actually starting the timer. I need something else to stop the timer. So I send the output to this change node, and what that does is it actually changes the payload. It sets it to stop. So in this case, as I say, if the device were to suddenly move, it goes over to the lounge, then it comes back again. It's going to re-trigger the node. It's then going to go to this little change node that I've got here. That's then going to send a stop message over to my timer, and it's going to stop the timer and the lights will stay on. Now, initially these rules that I've got did seem to work quite well, but after a short while I did run into a bit of a problem. So let's say, for example, I'm in the kitchen, and as far as the actual presence system is concerned, that is where I'm at. But then I get up, I go to the actual lounge, there's nobody else there, so it triggers the lights and the lights turn on. But then I come straight back to the kitchen. And I actually do that so quick that the actual presence detection system didn't notice anything change. So in other words, I'm stuck with a situation where the lights have been turned on by a motion sensor, but as far as the presence detection system is concerned, there's nothing to do. The actual occupancy state for that lounge hasn't changed. It's still, as far as it's concerned, empty, in which case there's no reason to turn any lights off there. And that was a bit of a dilemma. So for that reason, I had to restore a common sort of rule like this, where basically we have to have a countdown when motion's no longer being detected in the room. So that is the actual rule that I'm running at the moment for my rooms. I have this timer set deliberately, just in case somebody does actually walk into a room too quick and then walk straight back out again, because otherwise this part of the system just wouldn't work. Having said that, it then means I've got a rule here, which technically you could say isn't really needed anymore, but I do keep it as a kind of a fallback situation, and it does sometimes kick in. But for that reason, I increased the timer. The original timer was much, much lower than this. I think at one point it was down to about 2 minutes, but I've increased it to be 5 minutes so that it's at a higher countdown than this one. The reason being is the two are in conflict with each other when it comes to who decides to turn the lights off. And what I found is by having this turned up quite a bit higher than this one, this rule here acts as a kind of a fallback to this rule. In other words, it is quite possible that the timer here starts because everybody's left the room, motion's no longer being detected. So our timer starts, it expires, but it gets to this part here where it's checking to see if the room's empty. Either the presence system didn't catch up for whatever reason, or Murphy's Law, somebody's device just happened to have drifted and is actually reported as still being in this room, or is now in this room. As far as presence is concerned, the room is occupied. So that's why I've got this rule still exists. So instead of running this rule to turn the lights on, I'm still running this rule here, but I still keep this rule here as the backup to this rule. Now, as useful as I'm finding these rules to be, there is one situation that they don't account for, and that is during the winter time. In other words, that's a time of year when I'll be getting up and it'll be dark outside. Now, I could just leave the rules as is, and then as long as I'm moving from one room to another, eventually the lights will actually turn off. But to be a bit more efficient, I've got this rule here to actually turn the lights off when it gets bright outside. So let's say, for example, I'm in the kitchen, it's dark outside, I'm having my breakfast, then sometime afterwards the sun comes up and I'm still in the kitchen. Well, rather than just leaving the lights turned on because either the motion sensor still detects me there or because the presence detection system says I'm still there, I've got this rule where once we reach a certain light level outside, the lights will just get turned off. So very simple rule, we're just checking to see what the lux level is on this particular sensor. I mean, what you set this to depends on what your sensor is and what the light levels are for you. But once we hit that threshold, that's all it's going to do. It's just going to turn off all of these lights. Now, I do have other lights, so for example, ones that are in transit areas, they don't stay on long anyway, so I'm quite happy to leave those because they're just going to time out at some point anyway. Whereas these are rooms where I might stay for quite a bit of time, in which case it is worthwhile turning those lights off if it's bright enough outside anyway, and it's just no particular reason to actually have these lights on anymore. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.